Homework from New Lake, page number 46, question 259. Okay, so we've got a graph. And on this function, we've got it starting at -1 on the x and 2 on y. And then we've got this dot up at 3. And then the line comes straight down to 1, but that point is not included. And then it comes back up, and at 3, 3, it meets. Okay, so we want the limit as x goes to 1 of the function. So here's x. When it's going to 1 on this side, it's going towards 0. And when it's going towards 1 on this side, the function's going towards 0. So the limit is 0, just like the other ones. Alright, for the next part we have to give the values for x when f of x is discontinuous. So discontinuous means there's any point where you would have to take your pen off the paper. So for example, it's discontinuous at x equals 1, because we have to take our pen off the paper to keep going. And then again at x equals 2, and then here, because that function keeps going, that's continuous. So we've got 1, 2, 3 points. So x equals -1, 1, and 2. Alright, so for what values of x is the function 3? So now we're looking, where is it 3 on here? And it looks like, from the graph, sorry, that comes out like that. It looks like it's happening when x is less than -1, because it doesn't include -1, but from here on, that's where it is. And for when x is greater than or equal to 3, because this point is included. What x values are not allowed? Okay, so if you look at this function, x is defined there, x is defined there, x is not defined at 1. So x equals 1. This is for part D. X equals 1 and x equals 2. And then finally the last one, the limit as x goes to -1 of the function does not exist. And that is simply because when we come from this side towards -1, the function's going to 3, and when we come from this side, the function's going to 2. So because they're not going to the same point, it doesn't exist.